Welcome back to this last installment of topic 2. Once again, you will need to open your Excel file under topic 2 from Moodle, and once you open it, make sure you go to the sheet called Histogram. So in this installment, we're going to continue with more Excel graphs or charts, to use the Excel terminology, and this time we're going to look at histogram first of all. Now, most of you will be familiar with a histogram. It is used to show the frequency distribution of a sample or a population. So you have data. In this example, we have a class, and for each individual student, we simply have their score on a particular exam. If I scroll down the data that we have, you will see we go all the way to about 100, just over 100 observations. It's actually 105 observations. And we want to summarize this to find out, for example, how many people have received scores below 50 or between 50 and 60, how many people got over 70, 80, and so on and so forth. Now, you can do this by using functions whereby you can find this frequency distribution. There is a particular built-in Excel function called frequency, and this is something we call an array function. So it requires a bit of a special treatment, but it is quite lengthy and counterproductive, I think. So instead, you can use a graph which will give you all the basic details of the distribution, frequency distribution, and you will be able to show it graphically as well, which is quite appealing. So make sure that your cursor is placed anywhere inside this data set, this range of data, and then you need to make sure you are on the Insert tab on your ribbon, and then, as you are familiar now with, you go to this area here, to this group of charts. So what you need to do here is just under the tree map and sunburst charts that we saw in the previous installment, below that there is a little button icon, and the pop-up menu tells you that you can insert a statistic chart. So click on the drop-down menu and select the first one, the histogram. We're going to look at some of the other charts in a minute. So click on histogram, and there is your histogram. You see, you don't even need to select the range. Excel does it for you. I'm going to drag and make the chart a little bit bigger. So what do we have here? You can edit, of course, all these elements. What is measured here on the vertical axis are number of observations. In our case, number of students with scores within a certain range. And then Excel has created ranges automatically. So the ranges don't necessarily always make sense. So you see they go all the way to 102. There is a mark somewhere which is 100. So Excel will take the minimum and the maximum mark and will stretch a little bit the range, and then we'll try to separate into more or less equal sets. Now, how can you edit this? Well, you remember when the chart is selected, you have a new tab up here called Chart Tools, and automatically you have the design part, right? And the design part selects, for example, things like how you add chart elements, like labels, for example, a chart title, and so forth. It also allows you to change your data selection or even change the chart type. But there is another tab called Format. So under the Format tab, if you go right to the top left, you will see there the selection. Right now it says chart area. So this is because I've selected the entire chart. If I select, for example, the vertical value axis, you will see immediately at the top left the selection is a vertical value axis. The same thing if I select the series here, it will say series score, so it will give you the series name. If you drop it down, you see you can actually select a particular part of the chart or the entire chart area, right? And then you can say format selection. Now this will cause the pop-up format pane to appear. Okay, so here you are. Or you can simply double click any part of the chart and the format chart area pane should pop up on the right. Now what I would like to do here is I would like to change these ranges. I'm not very happy with them. Okay, so normally you want nice neat ranges. So what else can I do? click on this x-axis ranges, and then on the format axis go to the little histogram that you see here, axis options. So click on that, and then switch out or turn, if you like, the twisty arrow, and here you see something called the bins. Now a bin is the term given to a particular range. Our range can be from 0 to 10, from 10 to 20, all the way to perhaps 80 to 90 and so forth. And you will see that it is by default set to automatic, so this is when Excel does its own calculation of bins. But you can actually set your own bin width if you like, or you can simply select number of bins and then the width is set automatically. There is also a choice for an overflow and an underflow bin, which we're going to see in a minute. So let's say we want to normalize a little bit the ranges. We don't want them to be like they are now, every 9 marks. We want it to be every 10 marks. So I will click on bin width, and then I will go and select the 9 and turn it into 10. I hit return, and you see now my bins are 30 to 40, 40 to 50, 50 to 60, and so on and so forth. Okay, so this is now a lot more normalized. If you want, you can add, of course, things like labels, which is done as before. You can also select an overflow and underflow bin, as I said. Sometimes some of the information you don't necessarily want it to be shown in such detail. So for example, you want to focus on how many people altogether have grades which are below 50. So let's put an underflow bin, and the underflow bin, we're going to make it to be 50. So you see now all the people that have failed, have a low score, are concentrated into one bin with 3 observations, and this bin is less or equal to 50. And then the next one starts at exactly 50. That's why you have the bracket here, the parenthesis, and then it goes all the way up to just below 60. That's why you have the square bracket next to 60, and in the same way everything else. Now if you wanted, for whatever reason, to select an overflow bin for people who have grades of 80 and above, click on the overflow bin and change that to be 80. Right, so you have people below 50 and people over 80, and then the other 3 categories in the middle. So you have pretty much quite a very nice, very neat way to show the frequency distribution of your population or your sample. The next chart we're going to look at is a Pareto chart. Now, a Pareto chart, or the Pareto rule, if you remember, is when you're trying to identify what are the most important parameters in a population. In our case here we have a survey which was conducted by a restaurant, right? And they try to find, when passengers come back and complain about the service they receive, what is the most frequent complaint. So how can the restaurant improve their service by, rather than by trying to fix everything, instead to concentrate their efforts in fixing just a few things. So the Pareto rule is the famous 20-80 rule, which tells you that, for example, when you are selling a product, probably 20% of your customers generate 80% of your income, or perhaps that 20% of your product range generates 80% of the sales. So here we're trying to see if there is something similar, whether we have, for example, 80% of complaints are generated by 20% of the reasons for the complaint, and so forth. So once again, just make sure your cursor is somewhere inside the data range. Make sure that you select the Insert tab up here on the ribbon, and then go back to the Statistics chart. Right next to Histogram is the Pareto chart. Okay, so you will see, you even get a description. You use the charts to show the relative portion of each factor to the total, and you show the most significant factor. So you will see that in the little icon there, the columns are ordered from the highest to the lowest, and we're going to see this in a minute, and it shows you the additive effect. So if I click on that, there's my Pareto chart. I'm not changing any of the parameters, any of the chart attributes, like for example the chart title and so on and so forth. But what do we have here? The most frequent complaint is that the restaurant is too noisy. So perhaps the management can do something about reducing the noise, putting in partitions, or anything they may want to do. The next thing, they should concentrate their efforts, for example, on making sure that the restrooms or the toilets are cleaned frequently. Perhaps retrain their staff to make sure they are more polite to the customers, and so on and so forth. So the curve that you have here shows the cumulative distribution. So it takes each of these individual columns basically and compares them as a percentage of the total and adds them up. So obviously if you add everything up, this orange line is going to end up at 100%. But for example, if you look roughly at the first 4 complaints, right, and you come to this cumulative distribution, this pretty much touches the 60% line. So you could fix 60% of your complaints by looking at just the first 4 complaints. Okay, so the fourth one is probably the most difficult. The restaurant is too expensive, but perhaps concentrate on what is important. So this is the Pareto chart. Now I move on to the next chart, and this is called waterfall. A waterfall chart is good at showing a cumulative effect. So it shows you that every period, for example, or every time something changes, that change may be positive or negative. So you want to show it as a little step. So what we have here to illustrate this, we have the income and expenses, for example, from a product sale, from marketing sales. These are recorded on a monthly basis, as you will see here. Every period, right, you see this is the cumulative income if we tot everything together, and these are the cumulative expenses, and we have here an overall net, which thankfully this time is positive. But you will also see that for every month, the net effect of income and expenses, the net profit, let's say, is shown here in the third column. So what we want to see is how we fare each individual month. So you'll see there are some positive months, some negative ones, and there is a total. So in this case, to make a waterfall chart work, we should not include all our data. So if you simply put your cursor there, and then you simply select Insert, and then the waterfall is this little icon here, right? So of the 9 icons you have for the various types of charts, is this one. You can already see what it looks like, and it is this one, the waterfall. So if we insert this, you're not going to get a lot of information out of it. And you see all it does, it actually picks up the numbers from column B, from the first series. So this is not particularly helpful. So what I will do is delete this chart. I'm going to go back, and I'm going to select the months plus the line that says total. Okay, so cells A4 to A16. And I will tell you in a minute why the total one is interesting. And then you need to press and hold Control on your keyboard, or Command if you use a Mac, but Control if you use a Windows PC, and just click and select the range under Net. So this will give you the months, and for each month the corresponding net positive or net negative profit, and you're also selecting the total profit. And now you go to your Insert tab, go and find your waterfall charts and click on the first chart. Now this makes more sense. Let me make it a little bit better, a little bit bigger rather, so you can see it. So what do we have here? For every month you will see the cumulative effect. So the month of January added $1,851 or whatever it is to this overall total net income. February added a bit more, March added a bit more, April added a bit more, and so on and so forth. This is also quite interesting if you're making things like long-term forecasts and you would like, for example, to see what is going to be the effect of, let's say, the demand for oil for starting from now and then looking at it in 2030, 2040, 2050, for example. So each decade, what is going to be the addition, or it might be a decline as well for, let's say, demand for oil or total energy demand or whatever it is. So you will see the increases are shown by blue. You can change the color, of course. The decreases are shown by the negative here, the orange bits. So towards the end of the year, the last quarter, there is again increases. And then suddenly, as an additional point, you see the total number. Now, you may want to show the total in a different way. So what you need to do is click on it, and you will see immediately from the tiny little blue dots that the entire series has been selected. So you need to click on it again, right? And then you will see that the format pane is already open. I need to select this one, which is the series options, and there's a little box called set as total. So that's the key one. Click on that, and you see, if I go back to my chart, it has now turned a little bit different. Okay, so if you add all of these increases and decreases, you end up with a total, which makes sense. Okay, so you see eventually the last decrease equals the total number, right? And this is a waterfall chart. It gives you more of a sense of development, of progress in a series like, for example, profitability or forecasts and so on. The next chart we will look at is known as box and whisker. Originally it was known as box plot, so you may find this term in your readings. Effectively, what a box and whisker shows us are differences within a category, or categories rather, of a set of observations, of a set of data. It is quite commonly used when you want to compare different categories of data within the same sample or population. The example given here is taken from a medical test. So this perhaps looks at the score that the various patients achieved by using a number of different treatments, and in addition there is always a control group that received the placebo. So here you have the results of those patients that received the placebo, and if I page down, you will see there are 3 more treatments, A, B and C, and each one of them, each observation basically has a score. So put your cursor anywhere in the data range and then select insert, go to the chart group, and then it's a statistic chart, so click on this drop down and select box and whisker, and there's your chart. So what you can see here are these little boxes in the middle, and they contain from the first to the third percentile. So they look at the middle part of the distribution of the data. So you see where in that case the score goes from which point to which point. In the middle you see an X. This marks the mean of this particular category, which is the placebo. The line here, the horizontal line, marks the median of this particular category, and the whiskers show us the lowest value, the minimum, and the maximum value. So it shows you, for example, it tells you that the very first and the very last percentile are normally outliers. So if they are very close to the box, it means that there aren't many outliers, they are not very far away. If you look at the last one, treatment C, you will see that there are some big outliers, especially on the upside. The same thing you see for treatment A. If you want, you can add labels as well. So to add labels, you can simply add chart element from up here, or the easiest way, if you have Excel for Windows, is to click on the plus sign and then you select data labels. And you see by default you will get all the information. So for the placebo, you have a mean of 1650 score, a median score of 1814. You have the first to the third percentile, and then you have the fourth percentile and the 0th percentile, which is the minimum basically and the maximum values for this particular group. We move on to the next chart, and this is a scatter diagram. Now, you may be familiar with scatter diagrams. They usually look like lots of dots, and they look at they try to find the relationship between two sets of data, typically X data and Y data. So what we have here is a number of sales which are shown here. They can be, I don't know, 1,000 something of a currency or million or whatever it is, and how many calls they have been made. And we're trying to see whether there is a relationship between the number of calls and the number of sales. So if we increase the calls, do we make more sales? Now there are additional data. These are two lots of monthly data from 2 years. We're not really interested in putting any labels coming either from the year or from the month. What we're interested in are these two columns, the calls and the sales, and we need to highlight them because Excel will not find it easy to auto scan the data and select it itself automatically. Now always remember the sequence in which you put these columns of data is important, because the first of the two columns are going to be your X, and the second column is going to be your Y. So with the two columns selected, click once again on Insert on your ribbon, and then you already see the scatter, the little icon here. Okay, we're going to look at bubble chart in a minute. Right, see, this shows the relationship between two sets of values or two series. So there are a number of different scatter diagrams, so I'm going to choose the one where you simply have dots where the two observations can plot on the chart. If you want, though, you can connect them with lines as well, just lines without any dots, and these lines can be either curved or they can be jagged, whatever you want, straight lines, etc. So I'm selecting this one. Now I'm going to make this chart a little bit bigger so we can demonstrate what we can do with it. So you will see the dots here, they kind of point to some sort of relationship. There are some dots which are relatively close, there are some which look like outliers. You will notice from the data, from the numbers that you have put, if you look at the x-axis, the numbers go from 760 to 940, and this reflects the value range for the X data. So if you want, you could add labels. Before we add labels, we add the axis titles, and if we can go to the y-axis, we can highlight this, and then we know that these are the calls. So this is our X, and then if we can highlight this and this, we know then that these are the sales. So you can type it in so you know what it is that you're talking about all the time. Now the data as it stands doesn't look particularly exciting. So what can we do to actually give it a little bit more dramatic effect? Typically, and what a lot of people do, particularly in the press, in journalism and so forth, if they want to sell a story, they basically they alter the scale of the chart. So the scale we're going to alter here is the X, the vertical. So if you click it, on the right hand side, the formatting pane is already active. If it's not active, I've shown you before how to do it. The easiest way is to just double click those labels. Then go to the axis options, and then click on the little arrow here with axis options, and all you need to do is change your minimum. Now, where is your minimum value? It starts somewhere above 70. I think the first value is about 77. No, actually it's 75, is this value here, October 2012. So let's set the value here to 70, hit enter, and now your data starts looking a bit better, a bit more dramatic, and actually shows a pattern. So is there anything there that could imply that there is a relationship? Normally, you know that if you have X observations and Y observations, X in our case calls could be the so-called explanatory variable, so you can run a little regression, and Y might be the explained variable. So you see, the order in which you list the two data series is important, because you imply that your X variable is the explanatory variable and the Y is the explained variable. So is there a relationship between these? Well, what you can do is you can add a trend line, and a trend line can have several options. So before I select it, you see it can be linear, exponential, and so forth. I will click on more options to actually show you what these options are. So you will see that the line has been added as a dashed line, which can be formatted, and linear is the relationship which is selected by default. But you may recognize the other lines, exponential, logarithmic, and so forth. You can give the trend line name, you can edit it to a custom name. You can do a forecasting, okay, backwards or forwards. You can set an intercept if you want to, if you know what the intercept is. But sometimes it's nice to keep things simple. So all I will add here is I will display the equation, the relationship between the X and the Y, and I will also display the R squared. Now, if you have already done some econometrics, you will recognize this. Okay, so this is my equation, this is my line. I can select the line and I can go to the options there, and I can say that the line doesn't have any dash, it's actually a solid line. And if perhaps you'd like, I can paint it perhaps orange, so it's a little bit more visible. So now you see there is a sort of a line, a straight line that goes through these combinations of values, X and Y. There are quite a lot of values which are around the line, but also there are several outliers. Okay, there are several of these dots which are not close to the line. So you expect that the relationship may be there, but may not be as strong. So there is a relationship which has been calculated. So Y equals 0.09x plus 8.8. So technically means if you make, for example, 800 calls, the sales you're going to have is a factor of, you replace 800 here and then you calculate the Y value. And the R square gives you the strength of these relationship. The higher the R square is and the closer it is to 1, or the higher it is than perhaps 90, if you have an R square which is over 80 or 90, is actually a very strong relationship. This R square, and I should say 90, percent, so it would be 0.9. In this case, we have 0.4847 perhaps, so this is about 48%, or sorry, 49% perhaps. So the relationship is not that strong, but in some cases, this is strong enough. Perhaps it may allow you to try out increasing the calls and see if the sales increase, try to forecast. You can do something with it. So this is the scatter plot or the scatter chart. And I come now to, in a way, a similar chart, but it has a third dimension to it. This is known as the bubble chart. Now you may have seen them in various statistical data you may have encountered. In this case, the data are from a number of subjects who have gone on a diet program, on a weight loss program. So you see the names of the participants. There are not that many. You only have 3, 6, 8 participants. It gives you here the original weight, and the word weight has been misspelled here, so we can quickly correct it. So this is their weight in pounds. Okay, so it's not 285 kilograms, it's divide this by 2.2 and then you get the weight in kilograms. This shows you how many weeks they have been on a particular program. So there is a person here, Kevin, who has only practically just started 2 weeks, and there are 2 guys here who have been on the program for 18 weeks, and this is the weight loss again in pounds. So you would like to see the relationship between these 3. So how can you do it? I select these 3 columns, click on insert, go to the chart group, go to the scatter icon, and then I click on bubble chart. So you can have this one of the 3-dimensional. Perhaps I will select this, which is a bit flatter. I will make my chart a little bit bigger. Perhaps if I make it quite long, then there's not going to be that much overlap. Okay, so what do the bubbles show you? If I click on the bubbles, so I select all of them, right? So what it effectively shows you, there we are. So first of all, these are observations. You will see we go from point 2 to point 9. So this is 2, 3, 4, 5, 6, 7, 8, 9. Okay, but what we have here are 8 observations. We have 8 participants. Okay, so Excel kind of shifts everything to the right hand side by 1. So this first participant, you will see, is series 1.285. This tallies with the very first participant. So this is the original weight. Now, can we see it measured anywhere? No. So the size of the bubble reflects the weight. Actually, no, it's not the size of the bubble. It's the weight loss. Okay, so the size of the bubble, when you see size 31, it reflects this thing. Right, so what you can also measure is that the first observation, the 285, right, has been on the program for 12 weeks. So this is what is measured on the y-axis, and is the second participant, and the lost weight is the bubble, right? So you can carry on. You can go to participant, that's 2, 3, 4. Okay, so that's 0.275. This is George in our case, and he has been 18 weeks on the program, which is reflected by how high the bubble is, and then it also shows you how much weight they've lost, 34. So if we go to a smaller bubble here, this is participant number 5 effectively, although they have the number 6 here, so it's 5 plus 1. So this is participant Kevin, who has a weight of original weight of 290, has been 2 weeks on the program, which is measured on the vertical axis, and has lost 4 pounds, which is reflected in the size of the bubble. So when you want to show a third aspect on a particular chart, you can create a bubble, because the third aspect is the size of the bubble. We now look at a stock chart. Now, stock charts are going to be particularly useful because you're going to be dealing with company stocks. And in this example, I have downloaded data from Reuters Refinitiv data stream, and this is for Royal Dutch Shell. So these are simply share prices, and just to show you through the 4 different types of data, this one is the code of the company on data stream. PO is opening price, PH high price, PL low price, and just P is the settlement price. So this means the closing price. Now you can select some of these data or all of them to create an open, high, low, close chart. What I do not have here is the volume of shares traded, but you could also use these observations to create a chart. Let me start by making these columns a little bit narrower so we can create a bit of space. So we don't need to see the full titles here. So this is going to be enough. And all I will do here now, I will select the data itself. We don't necessarily need labels here. Okay, so I just highlight these four columns, 5 columns including the date, and then you see the data are not plentiful, but they are enough. So here we are. So we select this data, and then I'm going to move up a little bit to the beginning of my sheet. Once again, insert the insert tab from the ribbon, then go to your it should be here. No, it's not a combo chart. It is here, sorry, under waterfall. So this is where stock data are. Now you have 4 types here, right? You have more actually, but there are 4 types. This is your high, low, close, so it doesn't use all the data that we have available. The next one is the one we're going to use. It's also known as a candlestick, and you see you have to put the data in that sequence. So you have to put first the open price, then the high, then the low, and then the close price. The same thing for the previous type. So you have to put the high, the low, the close. So this could be done, for example, with the last 3 columns of our data. There is a type where you have volume, high, low, close, and also another one where you have volume, open, high, low, close. So in both cases we would need an extra column of data with the volume of shares traded. In this case, I'm going to select the candlestick, click on it, and here we are. Now you see you don't get a very exciting chart to start with, so let me bring it up here and make it a little bit bigger. So now you start seeing some variability. So once again, the trick here is we don't actually need series 1, 2, 3, and 4 because we know what each thing means. So I'm going to delete that. But the trick here is once again to manipulate the range, the scale of your vertical axis. So we observe that the prices for these few days are between around 25 to 35, let's say. Actually they're probably around 32, but 25 to 35 is a little bit better. So I double click that and I set my minimum to 25, and now we have a little bit of movement. By the way, if you look at any of the services that provide stock prices, whether they are on a website or whether it is Bloomberg or whether it is indeed Icon, Reuters Icon, they use the same technique. So they will give you a much more reduced range for the stock prices in order to accentuate, in order to emphasize the movement of this price. So in a candlestick, there's a very quick way to interpret that. Okay, you will see that a candlestick has a middle part, which the one looks like a candle, and a thin part, which is the so-called wick. So if we look at, let's take a good example. If we take this example here, right? So the lowest value here has been the lowest for the day. Here at the top point is the highest, so the lowest, you can see it popping up, 27.7. The highest value for the day was 28.94, and in the middle we have 28.415, and this is the opening price, and this one is 28.94, which is the closing price. So if the closing price, this one, is above the opening price, this is a good omen. This means that the share price is moving upwards during the day. So the box area is going to be white. If on the other hand you have one of these black candlesticks, again you have the lowest point, which was 30, the highest point, which is 30.95. Over here you have at the low point 30.21, and this is 30.95. But what is the difference now? That 30.95 is the open price and 30.21 is the close price. So the price closed lower than it opened. And you will see that if you go in the middle of the bar, it is going to label it as a down bar, whereas one of these white ones is an up bar. So every time the bar is white, it goes up. Every time it's black, it goes down. And in several different platforms, you will see these bars, for example, being blue or sometimes green if they're moving up, or red if they're moving out. And in many cases, this matches the numerical data. So you see lots of flashing red lights. It means the stock market is collapsing. And in an equivalent way, you should see the candlestick charts moving in the same way. If we want to change the style, so we can change it from here. So this is the open, high, low, close. We can select this one, but we actually have the wrong range. So if I click on that, actually it won't be able to show it to me. So in a roundabout way, I will first delete the chart. So you now need to go back to your data table, your data range. Highlight the first column which contains your dates. So I need to go a little bit further up. Then go back again. Press and hold Control on a Windows PC or the Command button if you have a Mac. And then click and drag with your mouse all the way down to this time highlight the high, low and close data. So here we are. This is our data. Then click on Insert. Go back to the stock data, but this time choose the first one, the high, low, close. And here is my data. And once again, let me first of all move it up a little bit and make it a bit bigger. We don't need the legend at the bottom. And we're going to change once again the minimum price, minimum value to 25. So now we can start having a look. You see, the high, low, close is not as easily visible as the candlestick chart, but within a day it shows you the lowest point, in this case 27.7. At the very top it shows you the highest point, 28.995, and there is a tiny little line, this 28.94, which is the close price. So the tiny little horizontal line is the close price. And there is a different variant which also contains the open price in this sort of format, and it would be a little horizontal line but pointing to the opposite direction. So perhaps stick to the candlestick chart because it is the easiest. We now move to the next sheet and we're going to look at a surface chart. A surface chart shows the relationship between two different variables and the way they move together and the way they meet in the middle. So here we have numbers which are not necessarily making any sense. You see here values from 100 to 103.3 and they move in increments of 0.3. And you see something similar at the top here, the top row, again values from 0 to 3.6 in increments of 0.3. And in between, the actual calculation is nothing more than the sum of the signs of the two numbers. But a situation where you would use a surface chart is if you're looking at the option prices for a particular asset. Let's say you have options on Brent crude oil and you have a number of different strike prices and you have a number of different implied volatilities, for example, and you want to be able to plot this together. So you create a data table like this with the calculations obviously here in the middle or with the observed values from the market, and then you select Insert and you go to this little cobweb here, which is actually a sign for the radar chart, which we're not going to cover here. So you click on that and you have this surface area. So the first one is a classic 3D surface. It looks like that. I'm going to put it on top of the table and then make it a bit bigger so you can see it. There you are. So what you see here is you have a three-dimensional chart. Over here you have the values in the top row from 0 to 3.6. On this side you have, so this is the Z dimension actually, so this is the X dimension, this is the Z dimension, and this shows you the values in the very first column of your table, and measured here on the X-axis are the values which are calculated by the formula given. So this is the sum of the signs of the two numbers. So you know, for a combination, for example, of 1.5 and say of 101.5, they meet perhaps somewhere here. Okay, so this is going to help you. It's a very similar visualization when you look at option prices. So you may need this particular type of chart unless the platform that you use generates one for you automatically. And the very final type of chart that Excel can offer you is not technically, it is a chart, but it is more like a mini chart. Okay, so what you want to create is a very quick way of showing the movements of data, right, across years, across lots of different cells in rows. So remember to put, the only way that Sparklines work is on data which is shown horizontally. So you will see here I have once again used oil consumption data from BP in 1,000 barrels per day. So in my column I put the various regions, and on the individual on the rows rather, I put the development in consumption for each region. So the first row, or rather row 6, shows you the consumption in North America from 2000 all the way to 2017. The same for the other regions. So let's say I would like to insert a little chart here at the end showing this development. Let me first close this format pane, and what I need to do is go to insert, and then you see there is a second group which is not under charts, but it's known as Sparklines, and you can put them as a line. You can insert a line or you can insert a column, which is what we're going to use here. But also, if you have, for example, prices that are moving up and down from one year to the next, you can show this as a win or a loss. Or you could have actually daily stock data. That would be quite interesting, because if the price on day 1 is at a certain level and on day 2 it falls below that, then it will be shown as a loss, right? Whereas if the price increases, then it will be shown as a win, which is a blue little bar. But here the data we have are increasing every single year. This is oil consumption, which goes higher and higher every year for pretty much all these regions. So we're going to use a column. So if I click on column, Excel will first ask you where the data are. So choose the data that you want to be plotted to create the Sparklines. So I'm going to choose this entire range. So you don't have to do it a row at a time. You can do all the rows together. You do not need the labels. Okay, the labels do not contain any numbers there. Sorry, apparently that was wrong. So I need to be here in the data range. So I'm selecting this range here, and then I need the location range. For the location range you need a single column, a single cell, which you can actually later on stretch, but you obviously need all the corresponding rows. So I'm selecting this column here. I click OK, and here we are. You have a mini column chart. We can make this wider so you can see them more clearly. And if you like, you can take your rows and increase these in height, right? So the actual spark lines are easier to read. So you see, the minute I select the first one, all of them are selected automatically. It's an entire range which has been inserted. If you go anywhere in the spark lines, you see that a new tab appears called Sparkline Tools. Click on it to go to design. You can change the style here, you can change the color. So you can put negative points or high or low points or anything like that. So perhaps if the low point is red, there we are. Okay, so you can see, sorry, the high point is red, so you can demonstrate that. We can also indicate a first point, perhaps in orange, so that a low point rather, so there we are. Okay, you can change again into a line or into a win-loss. You may decide to show the negative points, etc., etc. So the options are not as many as in a proper chart, but if you want a very nice quick summary together with your data, if you want your audience to primarily look at your data but also have a quick look at how the data develop and at which point a high point is reached, so it's a very nice quick visual way of demonstrating that. And with this I finish the second part of charts and topic 2 in Excel. So hopefully you have now quite a nice toolkit to put together quite nice chart that bring out the data work that you're going to do during the course and also in your professional life.